Lesson 9.1, Properties of Translations. Lesson 9.1, Properties of Translations. Example 1, Graphing Translations. To translate a figure in the coordinate plane, translate each of its vertices, then connect the vertices to form the image.
Okay, so, we can take a look at the coordinate plane and we can look at objects or geometric figures in the coordinate plane and we can move them around. And that's called transforming them. Taking a shape and doing something with it and moving it or having it exist somewhere else, some other configuration. Let's take a look at some examples where we can actually be very precise about different types of transformations. Here's one. Let's start with this triangle here, triangle XYZ. You can see it here in the coordinate plane. And our mission is to graph the translation of this triangle 4 units right and 2 units down. Now, what does that mean? It means that we take this figure just as it is, and we're going to move it 4 units to the right and then 2 units down. Okay? This is a translation. We're translating it. So we can actually see this visually by actually putting a movable congruent triangle right there on top of it. So there it is. And now I'm just going to follow the rules. 4 units right. So what does that mean? It means I go 1, 2, 3, 4 units to the right. And then I go 2 units down. 1, 2. And that's the translated version of X, Y, Z. And actually what I like to do is I like to call these things, quite often we call them, I'm going to use a blue pen, X prime, which is just X with a little attitude. Whoop. Y prime. Whoop. And Z prime. Whoop. And so you can see that this corresponds to the Z. This vertex corresponds to the X, and so forth. And if you actually want to find the coordinates, of course, we could read the coordinates off, right? You could see what they are, right? For X prime, oops, I keep moving it, sorry. For X prime, I see it's 1, 2. For Y prime, I see it's 3, -2, and so forth. But we could actually just use the rules and the original picture to actually figure that out. And I want to share that with you just really fast right now. Because you see what I could do here is take the coordinates of each point, which you can find. For example, what's the coordinates of X? Well, I go 1, 2, 3 units over in the left direction, so that's going to be -3 and then 4 up. Y is going to be -1 and then 0, because I'm staying on the x-axis, I don't go up or down. And then Z is going to be -4, 0. And now the rule is to do what? Well, since I'm moving 4 units over to the right, that means that what I do is, in all the X values, what I do is I add 4. That's a positive direction, so I add 4. But then simultaneously, I'm supposed to move it down 2, which means I'm going to now subtract 2 from the Y's. And so if you follow that rule, what we'll see here is that the X goes to a point which I'm calling X prime. And what do I do there? I take the X coordinate, and now I add 4. That moves it 4 units over to the right. And then I take the Y coordinate, and I subtract 2, because that moves it down 2 units. And when you actually work through this, what we see here is 1. So I see that X prime is 1, and 4 minus 2 is 2. And that's what we got. You see, 1, 2. That's the X prime. It checks. And now you can do this for each of them. It's the same rule. For Y prime, the corresponding vertex for Y, I take the X, -1, and I add 4. Everything, the X's are being moved over to the right 4, and then with the Y's, I'm going to subtract 2. And so here I see Y prime is 3, -2. Exactly what we have here. 3, 1, 2, 3, -2, 2 down. And then finally here with the Z, it goes to Z prime, and what I see here is -4, and I add 4 to the right, and then in the Y I subtract the 2, and so I see Z prime is 0, -2, so that's going to be 0 moving this way, but 2 down, and that's exactly where we are here. So now you can really see this, and by the way, this notation just means that that this is the coordinate that's associated with the z prime, for example, and so forth throughout. So you can see it really did go over 4 and down 2. Very cool. We, in fact, did a translation.
Okay, taking a slight different look at the lesson tutorial. The main thing to realize is whatever the rule is, like here it says graph the translation of triangle XYZ 4 units right and 2 units down. You have to be able to write the rule and the new location or the image. All right, like here we got the original x coordinate was at -3 and 4. What the rule says for the new one, x prime, you take -3 and you add 4 to it. So to every x value, you're going to add 4. To every y value, you are going to subtract 2. And then you do the basic math. -3 plus 4 is 1. 4 minus 2 is 2. And that gives you the new location. So you have to be able to do this graphically and algebraically. All right, when you go down and look at the y, the original position of y is here, which is -1, 0. But to the x coordinate for y, we add 4, and to the y coordinate for y, we subtract 2. This gives us a new location for y prime. And notice it's in the exact location. -1 plus 4 is a 3. 0 minus 2 is a -2. So if we come right here, that is exactly where we are. X is 3, 1, 2, 3, and y is a -2, 1, 2. That's where we are. And of course, the same thing would hold for z. All right, now make sure you have your definitions down. A transformation is a change in a figure's position or size. Translations, rotations, and reflections are types of transformations. A translation slides a figure along a line without turning. And of course, our key objectives: learn to transform plane figures using translations, rotations, and reflections.